Yay! Last chapter. So this next section is only 3 sections, 7.1, 7.2, and 7.3. And we're going to have our test next Friday, which is actually the last class day. Usually, if we hadn't have lost that week during spring break, there would have been more time to study, and I could have slowed it down a bit. That's what I had planned to do if you look at our original schedule. But anyway, we still get to cover all the material. I like this section. This is the law of sines, which is very important to physics. And you're going to, again, this is also used a lot in calculus. Okay? Because in physics, you're going to be dealing with objects and you're going to be dealing with forces. Like, for instance, you're pushing an object in this direction and it's resisting in this direction. But the angle of your force is being applied here. And you can make triangles out of everything. And from that, you can figure out the tension of how much force is applied in each direction. And the law of sines is used to find angles that would otherwise be really hard to figure out. So anyway, it's very popular. I like it. Okay. So basically the law of sines says given any triangle, the ratio, remember that's just a fancy word for division, the ratio between an angle and its opposing side are always equal. So here's an angle. Here's its opposing side. Let me actually highlight the angle in question. So there's the angle. Here's the angle. Here's its opposing side. And then here's the angle, and there's its opposing side. Okay, so you might hear some rumbling in the background. It's actually a thunderstorm's coming in. I apologize for the noise. Cats are freaking out. Anyway, so what this means is that we have, I guess I forgot to add in a word, the ratio between the sine of an angle. That's what I forgot. Typos. So this means that the formula means that sine of angle A divided by the opposite side, which we label as lowercase a. It's because of the law of sines. That's why we label the opposite side the same letter, so that the formula looks really nice and pretty. Is the same thing as the sine of B over lowercase b is the same thing as the sine of C over lowercase c. Now, since these are ratios, you could also flip these around and you could write their flipped version. It depends on what you're looking for. If you're looking for an angle, then use the top version with the angles on top. If you're looking for a side, use the flipped version, which we just get everything and we flip them. Okay, so this is what makes a triangle, this ratio. Now we often use this method when we know two angles and one side. There's other cases, but they save that for 7.3. Okay, so whenever you have two angles and one side, we know that, hey, let's use the law of sines. Now in this section, everything's going to be the law of sines, but let's get started. So in this triangle ABC, A is 30 degrees, B is 70 degrees, A is 8 centimeters. Find the lengths of B and C. So I'm looking for a length. So since I'm looking for length, let me try to label this. We're going to use these usually if you're looking for an angle. It just makes the math a little easier. And we use these if we're looking for a side. So I'm pretty sure my allergies are kicking in because I'm not sick, but my throat feels like there's like cotton in there. And then in the back of my head, it's like, you have the Rona. No. but I really doubt I do. Anyway, so, sorry, brain fart. What are we doing? Okay. So notice that we have the angle A. I guess I don't need to highlight all of it. We have the angle and its opposite side. And we want to find B. So here's an angle, and here's its opposite side. Now I'm looking for a side, so I want to use this version of the formula, where the side is on top. So looking at the formula, B over sine of 70. There's the rain. Is equal to 8, that's the side, over sine of 30. Oh, wow. Big storm. If it gets really big, I'll pause it, and I'll record later. Okay, so notice B, the side over its opposite angle, is the same thing as the side over its opposite angle. Now we could do the same thing with C, but notice I don't know either of them, so I'm going to solve that later. But now all I got to do is multiply both sides by sine of 70. Sine of 70. And you have B is equal to sine of 70 times 8 over sine of 30. Now this is where the calculator comes in. Sine of 30 is 1/2, but sine of 70 is a little nasty. So we just type in, make sure you're in degrees. We're dealing with triangles in this section, so everything's going to be in degrees. So we're in degrees, and so you just do sine of 70 times 8 divided by sine of 30. And I have 15.03. So I'm just going to round to the nearest number. When you read the homework, just be sure to read what it rounds to. So here I'm rounding to I'm rounding to 1 decimal place, which is still 0. So I'll say 15.0 centimeters. So there we go. Now the last part is to find angle C. I can easily find angle C knowing that this is 70 and 30 is 100, which means this has to be 80 because the angles in a triangle add up to 180. You don't need to show your work for that. But you do need to show your work for how you figure out what C is. So now I'm looking for C. Let me do a little shrinky. Shrinky dink. All right. So next we have, there's the severe weather warning. We have the side over its opposite angle, C over sine of 80, is equal to, and you can use either one you want. I'm going to use the A because this was given to us. If you, for some reason, you had messed up in figuring out what B is, and you use B to figure out what C is, then C is also going to be wrong. So I'm just using what they gave me. I know this is 30 degrees, and that's 8 centimeters. So this is 8 over sine 30. And I can do the same thing. I can multiply by sine of 80. Sine of 80. And there you go. C is equal to 8 over sine 80 over sine 30. Woo! What did I box that for? Sorry. You have to type it in. The storm is distracting me. I'm on my laptop, so even if the power goes out, my computer won't, but my internet will. So that means I'll have to re-record, and I'll be like the saddest person ever. 8 sine 80 over sine 30, and that gives me 15.8. I'm rounding to 1 decimal place. Again, read the homework carefully to see how much you need to round to. Let me make it the same color. There you go. So that's this is pretty much the trademark question for law of sines. They give you 2 angles on one side. It doesn't matter where the 2 sides are. Actually, well, there is one case where it won't work. but they're not going to do that to you in this section. And yeah, you just put the ratio, the sine of the angle, over its opposite side, and you compare ratios to figure out any missing variable. So I want you to try number 2 on your own. Okay, that'll be an extra example. Feel free to work on that. But I want to jump to the word problems. So this section is word problem heavy. Because yeah, you can figure out the law of sines, but let's use it in applications. So this first application says, a satellite is circling above the Earth as shown in the figure below. If you printed it out yourself, it's kind of hard to see what's going on here. There's the Earth going around. The colors they chose were kind of bad. When the satellite is directly above point B, angle A is 75.4 degrees. So I know this angle is 75.4 degrees. If the distance between point B and D on the circumference of the Earth is 910 miles, why did I put degrees? I don't know. So this is 910. And the radius of the Earth is 3,960. How far above the Earth is the satellite? So one thing we need to know is we have to look at our sector. Y'all remember sectors way back in chapter 2? Or chapter 3? So this is 910. This is theta. And these are 3,960, 3,960. So if you go back from way back when, the formula for theta is S over R. Okay? So theta is equal to 910 over 3,960. Get my calculator. 910 over 3, you know what? This actually, the zeros just cancel. This is 91 over 396 radians. I'll save the calculator work for later. Okay, so I know this angle, but notice that I know it in radians. I don't know it in degrees. And for the triangle stuff, we need it in degrees. So I need to do a little conversion. So theta is 91 over 396 radians. I need to multiply it by the conversion, which is pi radians is 180 degrees. So the radians will cancel out, and I can get my answer. And then I can round. So 91 over 396 times, you know what? Let me make it 91, put it in parentheses. 91 over 396 times 180 over pi. When you do pi, don't do 3.14. Actually use the pi in your calculator. For the TIs, it's second caret. And we get 13 point, let's do 2 decimal places, 13.17 degrees. Actually, since they gave me 1 decimal place here, I'll use 1 decimal place. Let's do 13.2. 13.2 degrees. So if this is 13.2 degrees and this is 75.4 degrees, I now know how much this angle has to be. I just do 180 because it's a triangle minus 75.4 minus 13.2, 91.4. All right. And so now I can use the law of sines to finish my problem. So this one just had some chapter 3 stuff in the front that you had to do. But once you figure out the angle, it's all happy. So I'm going to use, I want to figure out this side right here. Okay, the opposite angle is 91.4. And I want to figure a side where I know. Notice I don't know what this side is. So I'm not going to use it. But I do know this one. Oop, undo. So I know, and I'm looking for a side, so I'm going to put the side on top. I know that 3960, the opposite side is 75.4 over sine of 75.4 is the same thing as, now this side is 3,960 plus x divided by sine of 91.4. All right, so now all I got to do is solve for x. So I'm just going to multiply by sine of 91.4. Now I could be using my calculator and figuring out what the decimal versions of sine of 75.4 and sine of 91.4 are, but I'm not. I'm going to save that for the very end because we want to get the most exact answer possible. And if you're always using decimals whenever you have your sines, your answer is going to get more and more incorrect as you start doing more math to it. Let me put this in red. So sine 91.4, sine 91.4, those cancel. I'm going to do a little flipperoo as I write it. I'm going to put the x first. X plus 3,960 is equal to sine of 91.4 times 3,960 over sine of 75.4. And then, yeah, so all I got to do now is subtract 3,960. And that's going to give you your answer. So x is equal to sine. And as far as grading this for partial credit, this is where I'm able to actually see what you're doing. If you convert the signs into decimals, I can't follow your work. I don't know what you're doing. But if you leave them in signs, I can easily follow what you're doing and properly assign partial credit. All right, so now I can type that in my calculator and I'll get my answer. So sine 91.4 times 3,960 divided by sine of 75.4. And then minus 3,960. So I get 130.92. So I'm using one decimal place, so 130.9. So the satellite in this example is hovering 130.9 miles above the Earth. All right. Yay. All right, isn't that fun? Okay, so this is a classic test question. So next Friday, not this Friday, but next Friday, when you take the next test, expect to see something like that for problem for 7.1. All right. Now, because I'm feeling paranoid, I'm going to go check my notes just to make sure I got it right. Because I don't have my notes with me, and that would be very embarrassing. It is correct. Ha ha ha. Okay, next problem. This one's actually pretty easy. It's very similar to what we did over here. It's just that it uses the weird angles, the weird south by southwest notation that we did way back in chapter 3. Or was it chapter 2? I forget. Anyway, Tom and Fred are 3.5 miles apart watching a rocket be launched from Vandenberg Air Force Base. Don't know if that's real or not. Tom estimates the bearing of the rocket from its position to be south 75 degrees west, and Fred estimates the bearing to be north 65 degrees west. If Fred is due south of Tom, how far are each of them from the rocket? So first we're going to make our picture, and I'm going to use this first. Fred is due south of Tom. So we're going to have Tom, and then directly below him, we're going to have Fred. Okay? And we know that they're 3.5 miles apart. Oh God, he's coughing. I'm fine. All right. Now, from Tom, the bearing of the rocket is south 75 degrees west. Now, bearings are weird, and it depends on what book you read. But what I'm going to do is I'm going to move Tom's name a little to the side. And you put a little grid where Tom is, and it's south 75 degrees west. When they do bearings in this book, they measure them from the y-axis. So we have 75 degrees. That's actually pretty steep. Okay, and so you measure it from the y-axis. So they're saying that this is 75 degrees, while Fred estimates the bearing of the rocket to be north 65 degrees. So we draw another grid where Fred is. Worst grid ever. And again, we measure from, and let me use different colors. Okay. And then for Fred, it's north and then west. So 65 degrees, again, kind of. And so that would be 65 degrees. So reference angles are measured from the x-axis, but whenever they give bearings, just remember they're measured from the y-axis in our textbook. Okay, and so I'm going to keep on putting these out until they meet. And there they go. So they meet here, and this must be the Air Force Base. All right, so looking at this, we can see that we have a triangle. So this angle is easily identifiable. I just get my calculator. Don't want to think mentally right now. 180 minus 75 minus 65, 40. Not to scale. Yeah, this picture is not to scale. Okay, so we know that's 40 degrees, and they want us to figure out how far is, and I'm going to label this side as T, and this side is F. They want to find the distance of these two sides. And because I know this, I know an angle and its opposite side, I can easily figure that out. So we know that, let me write this out. And I'm looking for a side again, so I'm going to put the side on top. 3.5, its opposite angle is 40. Okay, so I got 3.5 sine of 40. Now for Tom, the opposite angle is Fred's 65 degrees. Okay, so for Tom, you have So that means it's going to be T over sine of 65. I'm not putting the degree symbols, but they're implied to be degrees. And whereas Fred is opposite angle. So now I have Fred over sine of 75 degrees. And we can easily solve by multiplying both sides. This case by sine of 65. This case by sine of 75. Boop, boop, boop. So T is equal to 3.5 times sine of 65 over sine of 40. Now, if for some reason the homework says exact answers only, this is what you would have to type in. This is the exact answer. No decimals. But usually the homework will say round to the nearest couple digits. So F is equal to 3.5 times sine of 75 over sine of 40. Okay, so we type those in the calculator. 3.5 times sine of 65 divided by sine of 40. 4.8 let's say 4.9. Yeah. I'm just trying to stick with what they had. They said 3.5, so I'm going to use 1 decimal place too. Let's say 4.9 miles. So Tom is 4.9 miles away, whereas Fred is, and I'm just going to hit second enter because it's almost identical. It's just that it's a sine of 75 instead of a sine of. So Tom is 5.3. Yay! Okay. Any questions? Oh, you can't answer because this is a recording. All right, so that's that problem. Now we go to one that's a little bit more complicated. It's not too bad. It's just kind of wiggy the way the picture is drawn. It says a hot air balloon is flying over a dry lake when the wind stopped blowing. Okay. The balloon comes to a stop 450 feet above the ground. So here's our balloon. There's a balloon. It's anchored. There's a little person in it. And usually the balloons have that kind of weird design. I don't know. There's my balloon. So they're 450 feet above the ground. At point D, a Jeep following the balloon. So this is apparently a road. That's a street. And along the street, a Jeep runs out of gas. Best Jeep ever. And the nearest service station is at point B, which is due north. So it's perfectly parallel. Not parallel, but in line with function. So here is the gas station. How do you draw a gas station? GS for gas station. How about that? All right, and then they give you all the angles. They say that the bearing of the balloon from the Jeep, so balloon from the Jeep, and when they say the bearing, they don't mean how high it is, they mean where it is on the floor. So the bearing from the balloon to the Jeep is 13 degrees, given to you. The bearing from the gas station to the balloon, is 19 degrees. And then the angle of elevation is 12 degrees. So I'm going to try to isolate the pictures. We have two triangles. Now the triangle that's standing up, basically the triangle between our Jeep and our balloon. We need to work with that first before we can figure out anything else. So here, this is point C. This is point D. This is point A. They tell us that this is 450. Here's our balloon. All right, and we got to figure it out. All we know is this. That is 12. Okay, so this is the angle of elevation. So this is 12. That's 90. So I can actually figure out the missing angle. Whoa, figure out the missing angle. So 180 minus 12 minus 90 is 78. So I know that this here has to be 78 degrees. Now, because of that, I can figure out this side. I'm going to label it as x. And we're just going to use the law of sines. So I have two opposite sides. Or sorry, the angle, its opposite side. And I have an angle and its opposite side. So x over sine of 78 is equal to 450 over sine of 12. And then from there, just multiply both sides by sine of 78. Sine of 78. So we get 450 sine of 78 over sine of 12. And we're going to round that to, I'll just do 1 or 2 decimal places. So 450 times sine of 78 divided by sine of 12. 2,117. So that's a huge number, so I'm just going to have 2,117. And this is in feet. Again, on the homework, it'll tell you how much to round to. The problems in the textbook usually don't say, so. All right, so I have 2,117 feet. So that's what this is right here. Yeah. Okay. Now notice that we're pretty much done because now I can look at the other triangle. And this angle here, this is 13 and that's 19. I can do 180 minus 13 minus 19 is 148. And again, looking at this, let me erase the little road I have here. I have an angle and its opposite side. And then I can figure out the distance. So I have an angle and its opposite side will be that length that I'm looking for. Okay, so I'm just going to call it the distance. So my distance over the opposite angle is 148. Is equal to sine of 19. Sorry, I told you to lie to you. 2,000, the distance over the angle. And then we just do what we've been doing. Sine of 148 to both sides. Those cancel. So my distance, my solution, is 2,117 times sine of 148 divided by sine of 19. And I'm going to type that in my calculator. Times sine of 148 divided by sine of 19. So 3,445. Since I'm rounding to the nearest number, 3,446 feet. Now, if you wanted to convert that to miles, you could. That's a good trick question that the homework sometimes throws at you. They'll write it in miles instead of feet. And so if they did do that to you, no fear. You just get your answer. And there's 5,280 feet in 1 mile. Notice your feet units cancel out, and your answer is going to be in miles. So you just do 3,446 divided by 5,280. So about 0.65 miles. Depending on what they're looking for, it can be either of these. All right, so that's that weird problem. You're going to see one like it on the homework, and so that's why I added it to here. So now you've seen an example. All right, next one. More physics stuff. This is where the physics comes in. Yay! And again, in physics, there's different ways to do it. Usually, if you were in a physics class, they would tell you to break this up into 2 separate forces. and those two forces must equal that force, and you create an equation, and then you have a force going this way and a force going that way, and that force has to equal that force because it's not moving. And so you have two equations, two unknowns, and you solve. But in this class, we actually have a simpler way to work on it. We're going to take the fact that vectors can be moved around. So if you want to analyze a vector, you can always shift it, and it's still the same thing. So in this picture, even though it looks really nasty, they tell us that the traffic light weighs 22 pounds. It's really light for a traffic light. Have you seen how big those things are? Anyway, find the magnitude of the tension. So how much force are these wires pulling in order to keep that traffic light stationary? So what we can do is I can just rewrite the forces. So there's three forces here. There's T2. I'm going to kind of separate them and make them a little so you can see them away from each other. There's T1, and there's W. I want to arrange these so that they form one triangle where I know all the angles. So here's my weight. Okay, so what I'm going to do is I'm going to get this guy, wrong color, and I'm going to put him right here. And so this is T2. It's a good movie. After I watched it, I'm still to this day scared to drink milk from a jug. Never drink milk from the carton. If you watch Terminator 2, you know why. Okay, so now let's try to figure out, oh, sorry, last one. And let me get this angle, and let me put him right here. Since it's not moving, all the forces will form a shape. And in this case, there's three forces, so they have to form a triangle. And so this is T1. All right, so let's figure out angles. Now, if I look at this graph, the 45-degree angle is in quadrant 2, going to the left. So here's my point. That means that my 45-degree angle would be right here. But because of some geometry, we have equivalent angles. So an opposite side, but equivalent angle. So this has to also be 45 degrees. Now for the other one, the 60 degrees, it actually works out. Notice the 60 degrees from where it starts is in the first quadrant. So I go back here, I look at where this angle starts, and the 60 degrees is already the angle I want. So this is 60, this is 45, and I can figure out the missing angle. If you want to freak your physics professor out, do a problem this way. I'm doing it the way the book does it. If you did it this way in a physics class, your professor would probably be like, "What?" And he would have to like look at it for a bit and be like, "Oh, well that's weird." But it works because we have a triangle. All right. So from there, notice that I have an angle, opposite side, and with that I can figure out what T1 and T2 are. So I have T1 over its opposite angle is sine of 45 is equal to 22. Its opposite angle is sine of 75. I also have T2, opposite angle is sine of 60, equals 22 over sine of 75. And we just solve each one. Sine of 45. Sine of 45. Cancel, cancel. Sine of 60. Sine of 60. Cancel, cancel. And so T1 is equal to 22 sine of 45 over sine of 75. All right. So now let's work it out. So 22 sine of 45 divided by sine of 75. 16.1 pounds of force. Let me look at my notes just to make sure I didn't make a mistake, because again, that would be embarrassing. Yep. And then the other one, I'm just going to second enter to recall the last thing I typed in, and I'm going to change the 45 to a 60. 19.7 pounds. A popular question in physics is they tell you how much pounds each rope can take before they snap, and they tell you how, if it's stationary, how heavy does the object have to be until they snap. Anyway, yay. All right, one more question, and then the rest I'll leave the other one for you to do as an extra example. Here's the Mamma Jamma problem. Dun dun dun. All right. A person standing on the street looks up to the top of a building and finds that the angle of elevation is 38 degrees. There she is. She then walks a block away, and she finds that the angle of elevation is now 28 degrees. Okay, so she walks away, and now the angle of elevation gets smaller. How far away from the building is she when she made her second observation? So the first thing you need to know about this is that these two triangles share a common side. In this case, I'm going to call it H. The missing side that I'm looking for, I'm going to call X. Okay, and we can see that the length of this would be X plus 440, which I'm going to write in a bit. All right, so because of that, let me zoom in again. I know my angles, so let's figure out my angles. 180 minus 90 minus 38. So the inner one is 52. It's kind of hard to write really small. Whereas the larger angle is 180 minus 90 minus 28, which is 62. So this angle right here is 62. All right. Just don't get confused about which one. 52 is my smaller one. 62 is the larger one. All right, so now let's look at sides. Let's use my law of sines. Looking at my first triangle, I can see that I have an angle and its opposite side. I have an angle and its opposite side. So I can create an equation. So I'm going to put, since I'm solving for sides, I'm putting the sides on top. So I have X over sine of 52 is equal to H over sine of 38. Okay. Now let's do the other one. Let me try to erase the highlighting that I did. Okay. So now I have an angle, oops, wrong color. The angle and its opposite side, and I have my new angle and its opposite side, which is all of this. So this new measurement is going to be x plus, so an angle, so the side and its opposite angle. So x plus 440 over sine of 62 is equal to, and then I have h over sine of 28. Now, in this problem, they could have asked you for either one. They could have asked you, how tall is the building? Or they could have said, how far away is she? It's the same question. Now, here, what they want to do is notice that they have the same height. But this is what I'm solving for. So this is the variable that I want to keep in the equation. I want to kill the h. So I solve for h on both sides, for both equations. Sine of 38, sine of 38. Down here, I multiply it by sine of 28, sine of 28. And we get new equations. I get h is equal to sine of x times, so sine of 38, x over sine of 52. Here I have h is equal to sine of 28, x plus 440, over sine of 62. Now, since they're both the same, I can now set these two equations equal to each other. And therefore, the h is now gone, and I can solve for x. So, that's part one of the problem. Part two, you have your equations set equal to each other. I love math. Oh. Now, I'm not converting the signs into decimals. It might seem like it would make it easier, but every sign you do, you'd be rounding. And having all those roundings and all those dividing a rounded number by a rounded number gets a worse rounded number. So I'm keeping everything exact. Okay, so all I got to do is solve for x. So I don't like denominators. So one thing I'm going to do is I'm going to do the whole cross multiply thing. I know as a teacher I shouldn't say it, but I'll run out of room if I do it the long way. So if I do my cross multiplying thing, I have sine of 62 times sine of 38 times x equals sine of 52 times sine of 28 times x plus 440. Gross. Okay, so I want to solve for x. So one thing I can do, I can get this, I can distribute it. Let's write it all again. All right, almost done though. 440 sine of 52 sine of 28. Right, now all I got to do now is subtract this to the other side. So, boop, boop. Ugh. Let me move this to the side to give me a little more room. And let me just shrink everything just a bit. I read an article that the reruns you watch on TV are sped up by 7% so that they can fit in more commercials. Isn't that fun? These are the things I'm reading during quarantine. So, sine of 62, sine of 38x, minus sine of 52, sine of 28x, is equal to 440 sine of 52 sine of 28. Kind of ran out of room there. Okay, but notice that these things have an x in common, which means I can factor the x out. Math is fun. And couldn't fit it. Let me make this go a little higher to the side. Sorry, I'm doing some cosmetic surgery on my trouble. Too tiny. All right, so this is 440 sine of 52, right? Yeah. Sine of 28. And so my last step is I divide by all of that gobbledygook. Right? And so my final answer, look at all that empty space that I left for that looking for thing, just taking up all that space that I could be using. Okay, so after you divide by all of that, you get your final answer. X is equal to 440 sine of 52 sine of 28 over, and then you have all that stuff that we divided by. Sine of 62 sine of 38 minus sine of 52 sine of 28. So I type that in my calculator, and I have 440. So first, before I even start, I'm going to do a parentheses for my numerator. 440 sine of 52 sine of 28 divided by, notice, and I close the parentheses. So I close the sign, that's the first one, and then I close the parentheses for the numerator, divided by, open the parentheses for the denominator, sine of 62, close, sine of 38, close, minus sine of 52, close, sine of 28, close, and then close for my denominator. And I get 937.4. Okay? And even then, you type it in, and you'd be incorrect. The reason is this isn't the final answer. This is in feet. The answer says, how far away from the building is she when she makes her second observation? So notice that we found x, but we need to add 440 to it. So I'm going to, for space issues, I'm going to write it up here. 937.4 plus 440. (1,377.4 feet). That's how far away she is from that building. So notice I could have solved for x or h. This is what people do when they want to measure the height of a tree, or when you see people measuring the height of a building when they're surveying an area, except they have an equipment to do it for them. So they put their piece of equipment down in the first point, and it measures the angle. They put their equipment down in the second point, and then basically after it figures out that angle, it does all the math, because you can make a program that does all this, and it'll tell you how high the building is. It's even more fancy because it takes into account the curvature of the Earth too, but that's different. That's more fancy. All right, so this next one is very similar. So give this one a shot, and I'll post the video that has the answer to number 8 and the answer to number 2. All right, have a good day.